Hey guys, welcome back. This is Mr. Jet. We are going to begin our next section today. We're going to start talking about solving exponential functions. So we're going to spend a couple days on exponential functions, and then we'll talk about solving logarithmic functions. So first things first, let's just kind of look at a little bit of review. So remember, if we have this common log, okay, where we have log with no base, that simply is telling us base 10. So this is base 10. Remember here our natural log has base e. Okay, so this is the same thing as log base e of x. We just don't write it like that. Over here, okay, what we're going to talk about today is solving. So we're going to talk a lot about inverses. So remember, when we solve any equation, we're always just taking the inverse of the function, of the operation that's going on. So in this case, we're adding, so we know that the inverse of that is subtracting. So we get x equals 7. Here, we're square rooting, so we know the inverse of square rooting is squaring both sides. So we get x plus 1 equals 16, which gives us x equals 15. And then same thing here, we're cubing, so we know the inverse of that is to cube root both sides, and so we'll get x equals 3. Okay, and so today, everything we're going to be doing the same thing. We're going to be taking the inverse in order to solve the equation. Well, when we're talking about exponentials and logs, they are inverses of each other. Okay, so a logarithmic function here, log of base b, is the inverse of the exponential function with that same base b. Okay, so as long as they have the same base, we're looking at these two functions, a log and an exponential, that are inverses of each other. So they cancel each other out. So they let us solve them. So if I look here, if I have this exponential base b to the x power, and I log that, so I take log base b of that, log and the exponential are going to cancel each other out, and it's just going to leave us with this x. Okay, and so because they're inverses, same thing here. I have this exponential here with base x. I have this log here with base x. So they're going to cancel each other out. They're going to leave us with just x. Same thing over here. I have log base b. I'm going to take that to the exponential with base b. The exponential and the log are going to cancel and leave us with just x. Same thing here. Log base e, exponential base e. They're going to cancel each other out and leaves us with just x. Okay, and so we're going to use logs and we're going to use exponentials to be able to solve these two type equations that we're going to look at. So before we actually get to the equations, let's look at how this works. So again, if I have an exponential with base 5 and a log, and I take the log of that exponential with base 5, they're going to cancel each other out. It's going to leave me with just 2x. Same thing here. I'm going to take log base 9, exponential base 9, and I cancel each other out. It's just going to give me 4x. Here I have exponential base e. I'm taking the log base e of that. They're going to cancel out. It's going to give me x squared. Okay, same thing over here. Log base 10, exponential base 10, leaves me with 4. Log base 3, exponential base 3, leaves me with 5. Log base e, exponential base e, leaves me with just 4. Okay, so what we're going to look at the next couple of days is just exponential equations. So we'll talk about logarithmic equations later. When we have exponential equations, it's just like you would think it is. It's an equation that has a power that's a variable. So no log in the equation. We're going to look at two different types. The first type that we're looking at is this one here. We will look at this one tomorrow. Okay, so the first type we're going to look at today, it just has one exponent, one exponential here. This side doesn't have anything. Okay, so in this case, so where we can't make the bases look the same, what we're going to do is we're going to isolate the exponent. So if there's anything outside of whatever our exponent is here, if we're adding or subtracting or multiplying, and we'll isolate that first. And then we're simply going to take the log of both sides, okay, because that's going to be our inverse. That's going to cancel it out. That's going to solve our equation. Now, if I look at this one here, we probably should be able to tell that this is going to equal 3. Okay, because we know that 2 to the third power gives us 8. But what we're going to do here, all right, I already have it isolated. So the way I can cancel this base out is by taking log base 2 of what I have. Okay, because we know that log base 2 and this 2 are going to cancel each other out, leaves us with just this. Well, if I take log base 2 on the left side, I have to take log base 2 of the right side as well. And so over here, these are going to cancel, leaves us with just x. On the right side, we're left with this log base 2 of 8. Now, that is the exact answer. Sometimes on an ACT or a multiple choice, that would be your answer. If we type into our calculator, like we said above, if you type in log base 2 of 8 in your calculator, that should give you 3. So on a non-calculator question, you would get this. And if you could type into your calculator, we'd get this here. Next one, same thing. Exponential is already isolated. So we're going to take log of the exact same base we have here. So we have base 6 here. So we're going to do log base 6 of 6x. Log base 6 of 54. Okay, over here, again, log base 6 and exponential base 6 cancel each other out. Leaves me with x. Over here, on a non-calculator, that would be your answer. If we have a calculator, we can type that in. If we type in log base 6 of 54 to your calculator, you should get 2.23. Okay. On the last one here, our exponential is here. So we have to isolate that first. We have to get that 3 out of there first. So as we know, we're multiplying by 3, so we're going to divide both sides by 3 first. It's going to leave us with e cx plus 2 equals 5. Now, we need to log this side to get rid of that e. So we have to think about what is the log with base e. Well, we know that's the natural log. So natural log of e to the x plus 2 equals natural log of 5. These two are going to cancel out. We're going to be left with x plus 2 equals natural log of 5. When we subtract 2, we'll get natural log of 5 minus 2. Remember that minus 2 is not with the log. It's natural log of 5 minus 2. Again, that would be your exact answer without a calculator. With a calculator, we're going to get negative 0.391. Okay. All right. I want you guys to go ahead and try these 3 problems on your own. So pause the video, try these 3 examples. When you play the video, the answers will be there. All right, guys, here are your answers. Check those, make sure you understand what you did correct, what you might have made mistakes on, and then go and do your practice.